Let's continue to develop this idea of a quadratic function in standard form. In the previous video, we looked at how a scalar in front of a quadratic would either compress or expand the vertical shape of the graph. And in this video, we're going to look at how it will either slide left or right based on how we change the x minus h binomial inside the part that is squared. So just as before, if a is greater than 0, the parabola is opening upwards. And if a is less than 0, the parabola opens downwards. But if you include this idea of an x minus h as part of your square in the parabola, then it will shift the function either to the right or to the left an amount h. So then our vertex becomes h0, and our axis of symmetry slices right through the value of h. This is what it means when the vertex is at h0 and the axis of symmetry is x equals h. If h is positive, the graph of y equals ax squared is shifted h units to the right. That's like this second example here. If h is negative, the graph of y equals ax squared is shifted h units to the left. So we don't have a visual example here, but that statement does hold. And then finally, we have two more statements. For a greater than 0, the range of f is 0 to infinity and has a minimum function value of 0 when x equals h. And for a less than 0, the range of f is from negative infinity to 0 and has a maximum function value of 0 when x equals h. Now you're welcome to try this by manipulating a function of this form. Let's go ahead and graph a function of the form f of x equals ax minus h squared using Desmos.com and add a slider for a and h. From our previous video, we have ax squared, so now we need to wrap the x in a set of parentheses. And include an h in there. Don't forget to put a minus with it. And it asks you to add a slider for h, which we will do. I'm also going to leave the x squared as just the standard graph that we can compare all the others to. In fact, I'm going to label it as black so we can remember that that's the standard function. Now the blue function represents a x minus h quantity squared, where h can be scaled, and notice when I move h, the function should shift left and right, which it does. Let's also try observing what a will do. And I'm going to change my slider from negative 10 to 10 on the a value. Now when we scale this, we can see how the parabola would change value or height based on a. If a is positive, the function will open upwards. If a is 0, the function is a horizontal line along the x-axis. And if a is negative, the parabola opens downwards. We can also shift h so that h is 0. This shows us that it could be symmetric about the origin, but if we shift it negative as the vertex, then h in this case is negative 10, and notice that if you have a negative negative, your value inside would be representative of a positive h, because x minus a negative h becomes a positive h. In this case, it would be x plus 10, quantity squared, would give us this parabola, and a equal to 0.1 gives us this nice wide open kind of flattened parabola.